Okay, our last sample problem on forces in space. Okay, so this was a board exam on our time, May 2019. And that time, dalawang situation yung lumabas dito. Okay, tripod problem. Okay, so for the given tripod, here, if W is 60 kilonewtons, compute the axial load on member AB, AC, and AD. Okay, so dito sa number 2, if may allowable load yung each leg natin as 50 kilonewtons, we will calculate the maximum value of W. So, naging baliktad siya. Okay? So, dito, if W is 60 kilonewtons at A, is horizontal along positive x-axis. So, nag-iba yung orientation ng W natin dito for number 3. Okay? So, anyways, let's solve muna yung number 1. Okay, so how to calculate this? Okay, take note that this is a force, these members are two force members. Okay, walang load in between the body and only loaded in between 2 points. That means, in each member, we have here an axial load. Okay, so klarong-klaro. Okay, parang nag-analyze lang tayo ng thrust dito. Okay, so first thing to do here is we will locate the coordinates dito. Okay, coordinates ng ating nodes, kumbaga that one. So unahin natin yung nodes. And by the way, ito no, if we analyze this like a truss, then we can do just method of joints dito at joint A. Okay, and we assume that the forces here will be in tension, okay, away from the joint. Okay, and again, coordinates, ayun, ito yung coordinate ng A natin. Okay, wala siyang x, 0 yung x. Yung y natin is 1.35, that one. Okay, that node A. Then wala siyang z. Nasa origin siya. Okay, now, the coordinate of our B, this one. So, our x is 1.5, yung y is 0, yung z is also 0. Okay, saktong-saktong nasa x-axis siya. Coordinate of our C, that one. So, for C, the coordinate of x is behind the x-axis, no? Or nasa left. So, that should be negative 0.6. Then, our y-axis, of course, wala siyang offset along y. So, 0. That one. Then, our z, coordinate of the z is from this point. Take note, the z is along this direction. That is 1.35 positive. Okay, for our d naman, that one, that will be, okay, yung x is negative 0.6, this one. Yung y is 0 pa rin. Yung z is doon sa likod. So, negative 1.35. Okay, so after this, we can just solve our vectors. Okay, unahin natin yung vector B. Vector AB rather. Okay, sunod-sunod natin, AB, AC, and AD. According to this arrangements sa question, okay, para hindi na tayo malito or hindi na tayo ma-confuse mamaya. So, AB, AC, AD. So, unahin natin yung vector AB. So, that is just by subtracting the coordinates. So, coordinates of B minus the coordinates of A. So, ganito lang yan. So, that will be 1.5 minus 0. That will be 1.5 of I. Okay. Then, 0 minus 1.35. That is minus 1.35 of J. And 0 minus 0, that will be 0 of K. Okay, klaro? Then, ito yung magiging unit vector natin. Okay, so, that is just this vector divided by the absolute vector. Or kumbaga, that is just this vector divided by the length of that length. The length of this member AB. Okay, so let me show you this. Pakita ko na lang. Okay, so that is in vector mode. So that will be mode 8, that one. Then, let's say that is in vector A. Okay, 1. Okay, so just input this vector dito. And 1.5, then negative 1.35. 35, input lang. Then, 0. Then, I will press CA. Then, this unit vector, that will be the vector of that line divided by its absolute vector. Absolute of vector A pa rin. Yan lang yun. Parang vector over the length. Actually, this absolute vector is just the length of member AB. Okay, if we press equal, that one, so ito yon. Okay, yan yung lahat. Okay, negative 0.6689 and we have 0. Okay, so this unit vector pala will represent the x o y and the z axis of that force. Okay, as you can see, this member AB, wala siyang component along z, kaya 0 yung component z dito. Okay, klaro? And similarly, sa member AC and member AD, the same lang. Okay, just follow lang that. Okay, I know you can follow na that. The same manner kung ano yung ginawa natin dito. Okay, and the unit vector, that one. And member AD, that one. Of course, D minus A, because we assume all the forces are tension. So, our head should be dito. Then, the tail should be at point A lahat. Kumbaga, change lang natin dito yung origin natin. Kasi, yung ginawa natin dito, nag-change tayo ng origin from this point up to that point. Okay, kaya ganito yung ginawa natin. Then, the same. Then, ito yung unit vector. Again, that is just the vector over the absolute vector. Okay? Now, yung magagamit natin dito is yung unit vector lang. That one. Okay? So, I said kanina that this component, this unit vector is just the representation of the component of the force. Okay, so just like the thrust, if this is at joint A, so we analyzed method of joints, diba? In 2D, we can do summation of forces vertical and horizontal. Well, in this case, we can do summation of forces horizontal, along Y, along X, and along Z. So, tatlong equation yung gagawin natin. Okay, so let me show you this. Okay, so let's say, we say summation of forces. So saan ba yung summation dito? I think nandito yan. Okay. So let's say summation of forces. Hindi ko na alam saan yung summation dito sa MATCAD. Ito. Okay. Summation of forces. Unahin natin yung along X. Okay, so ganito. Na that should be equals to 0. Okay, equilibrium lang. Klaro ba? That should be equals to 0. Okay. So, yung X natin dito will represent ito, yung puro I. Yung may I. Diba? Yung I represents X, yung J represents Y, yung K represents Z. So, lahat ng I natin dyan, yan yung titingnan natin. Okay, so ganito yan. So, this will represent the force in member AB. So, that will be 0.7433 of member or force in member AB. Okay? Then, minus this one. Again, titingin tayo sa lahat ng nasa I. So, minus this one. This is force in member AC. So, that will be 0.2998 times the force in member AC. That one. Okay? Now, this one. Force in member, this should be member AD, okay? Minus, the same pa rin, 0.2899 times the force in member AD, that one. Then, equate natin to, ano yung equate natin dito? Okay, so as you can see in this figure, walang force, external force, along X direction. So, that should be 0. Okay? Parang tinignan lang natin ito. Okay? Now, another equation, of course, summation of forces along Y. That one. So, naging Y na ito. Klaro? That one. So, ang equation natin dyan, that will be, titingin tayo sa J. So, minus 0.6689 times the force in member AB. That one. Then, ito naman, minus 0.6746 times the force in member AC. Okay? Then, again, minus 0.6746 times the force in member AD. Ayun. Then, take note, in y direction, may force tayo dyan, may external force, which is the weight. Okay? And it is also going downward. That is 60 kilonewtons. Since that is going downward, so minus pa rin yan. Minus 60 kilonewtons. Then, equate natin to 0. Klaro ba? Okay, this is our equation 2. Now, equation 3 is summation of forces along Z. Okay, so I will just change this. That one. So, titingin tayo sa K. Diba? K represents the Z. So, that will be 0 of force times the force in member AB. That one. Then, plus 0.6746 times the force in member AC. That one. Then, minus 0.6746 in the force in member AD. Then, walang force along Z dito. So, that means that is equals to 0. So, these are our equations. 3 equations. Okay? If you will do that in the calculator, that one, okay, that is in mode equation 5, then hanapin yung 3 unknowns, and that is in 2. Okay? So, just input the coefficient. That will be 0.7433. Okay, next, that one, negative 0.2998. Then, next one, negative 0.2899. I think this is 2998. Okay, na mistype ko. That should be 2998. Okay, let me see lang. Okay, 2998 yan. Nagkamali ako dyan. Then, in our D, of course, walang dito sa kabila, 0 siya. Or walang constant dyan. Then, equation 2, this one, negative 0.6689. Then, medyo matagal dito, no? But in your calculator, madali yan kung actual, no? Then, negative 0.6746. Then, the same, negative 0.6746. Then, this one, this 60, i-transpose natin yan sa kabila. That will be positive 60. Okay? Kasi ganun yung format ng mode, kumbaga 3 equations, 3 unknowns. Dapat yung constant nasa right side ng equation. Okay? Then, this one, that should be 0. Then, 0.6746. Then, negative 0.6746. Then, 0. Okay? If we press equals, so ito yung simultaneous answers natin. This is for force in member AB, force in member AC, force in member AD. Of course, yung member AC and AD dapat equal sila, no? But, because as you can see, symmetry yung orientation nila. Okay? So, this is just the concept. Parang nag-analyze lang tayo ng truss at joint A, method of joints. Okay, so that is one technique. So actually, we can, pwede tayong malito, no? Because pag ganito yung tingin natin, kumbaga, pa-vertical yung equation natin dito. But actually, we can do this on matrix form. Okay, ganito yan. For the members, pwede natin gamitin yung matrix. 3x3 matrix, gawa ka ng matrix din, then just input that one. Okay, input yan lahat. Lahat ng kuan dito na coefficient. That one. So, i-input natin yan sa calculator. Then, for the load, for the external load, so 3x1 matrix yung gagawin natin. Again, another technique ito, ha? Baka malito kayo. So, ganito yan. 3x1 matrix. Then, here, our x, wala tayong load along x. That should be 0. then in our y-axis, may load tayo. That is downward force. Of course, that should be negative. Gagawin natin dito is unit load muna natin. Okay? Minus 1. 1 unit load. Pwede natin idiretso yung 60 dito. But, I advise ito yung gagawin natin. Okay? So, makikita nyo yung advantage. So, I will just put a unit load, negative 1, since that is downward. Then, along Z, wala tayong load. Then, ilalabas ko lang yung W dito. Okay? So, ito yung i-input natin sa calculator. Okay, let me show you that. Okay, so nasa matrix na tayo dito, ha? Okay, that is in the mode. Nasaan yung matrix? Mode 7. Then, gawa tayo ng matrix. Sabihin natin tong for the members 3x3 sa matrix A. 1. Then, that should be 3x3 matrix. Hanapin yung 3x3 matrix. That one. 2. Then, just input 7, 4, 3, 3. Then, negative 0.6689. Then, 0. Then, negative 0.2998. Then, negative 0.6746. Positive 0.6746. Then, negative 0.2998. Negative 0.6746. Correct? Negative 0.6746. Okay. Now, after that, we just input the data at matrix A, then press CA, then gawa ulit tayo ng matrix dito for the loads. So, dito na tayo sa apps. Then, gawa tayo ng data. Then gawa natin siya ng matrix B. We will input this one to the matrix B. So, 2. And again, that should be 3 by 1. So, press down arrow key. Then, 3 by 1. Okay, so that one. So, just input this one. So, that should be 0. Negative 1. And 0. Okay. Then, I will press CA. So, may data na tayo lahat. Then, after that, ito yung i-input natin. Kumbaga, yung syntax. Negative transpose of matrix inverse matrix A times matrix B. Okay, ito yung syntax. Then, it will give us simultaneously the answers dito. That one. So, ang lalabas dito is the ratio. Okay, in terms of W yan lahat. Okay, so, ganito yan in the calculator. So, that will be negative transpose. So, I will put negative, then hanapin ko yung transpose. Eto. Okay, so I just ups, then press down arrow key, TRN. So, 2. Then, hanapin yung matrix A. So, ups pa rin. Then, matrix A at 3. Then, dapat inverse yan. Okay, raised to the negative 1, this one. Okay, then, hanapin yung matrix B. Ups, then matrix B is nasa 4. Then, if I will press equal, ito yung ratio nila. That one. Negative 0.4271, negative 0.5294, the same dito. Okay? Yan yung ratio nila. So, as you can see, that is negative since alam natin, or klarong-klaro man siguro na this member will be inducing a compressive force. Okay? So, after that, that are the ratio. So, how can we calculate our forces? So, ganito lang yan. To calculate the forces, since we have the ratio, okay, so the force in member AB is just 0.4271 times 60. Okay? Or times W. This one naman, the same. I-multiply lang natin sila lahat ng W, and ito yung corresponding forces nila. And as you can see, the same sa ginawa natin sa yung kanina, yung ibang solution. Okay? That one. Okay, klaro? Okay, so rewind nyo lang yung video para ma-master nyo yung technique dito. Now, dito, if the allowable compressive load of each leg is 50 kilonewtons, what is the maximum value of W it can carry? Okay, kaya ginawa ko kanina is pinalabas ko yung W sa ating matrix kasi kaya dahil dito for number 2. Okay, so take note, we have these values kanina, the ratio times the W. So, ano yung W daw? Say W, if the allowable compressive load in each leg is 50 kilonewtons. So we will just input if AB is 50, okay, assuming if AB is 50, that is the allowable compressive load. Therefore, our W is 117.07. Ito lang yun. AB 50 divided by 0.4271. Okay, so we will investigate ano yung safe W. Now, if AC is 50, our W is 94.45. Okay, just divide 50 divided by 0.5294. Then, if AD is 50, then divide that one. So, the same na yan. So, as you can see, the safe load W here is just this one. Dapat mas maliit na value yung ilalagay natin dyan para safe talaga. Okay? So, that one. I hope na-gets nyo yung purpose ko kanina. Bakit I assume na sa matrix B natin kanina na I will assume a unit load. Dahil dito, kukunin ko lang yung ratio nila para if babalik ta rin yung tanong sa problem, kumbaga yung W na yung itatanong, diretso na lang natin itong magagamit yung ratio nila. Okay? Gets? That one. Now, for number 3, if the W is 60 kilonewtons, this one, and is horizontal along positive x-axis. So, that means ganito na yung orientation niya. So, compute the loads in kilonewtons in each leg. Okay, so as you can see, ano yung nagbago? Yung load, yung orientation ng load. So, ang babaguhin natin sa data natin, in the calculator, dapat yung sa load lang, or sa matrix B. Okay, so hahanapin natin yan, matrix B. Okay, 4. Okay, equals tayo. Ito yung matrix natin. So, ang nagbago dito is that one, W. So, yung load natin is nasa x-axis na. Meaning, ito yung nasa x-axis, y and z. So, andito na yung load natin. So, pwede natin ilagay 1 unit dyan. No. Okay, so, that one. Okay, I will just input 1. I can edit the data. So, dito na, mode 2. Then, matrix B. Okay, nag-mode 2 lang ako ha. Then, I will edit the data. Dito, magiging 1 na yan along x-axis. Then, wala na tayong load along y-axis. So, 0 na siya. And take note pala, naging positive na yan because that is along the positive x-axis. So, in the z-axis, wala pa ring load. Okay, so actually, I can just put 60 na dito. Okay, kasi wala nang kasunod ang problem dito. Okay, unlike kanina, may kasunod siya. Binaliktad na ang papahanapin is yung W na. Kaya, I assume 1 unit load. Okay, dito, idiretso ko na lang 60. Okay, so I will press, okay, we save the data for matrix B. Then, the same approach or the same syntax. Okay, actually, the same lang. Ito lang yung nagbago. Okay? Okay, so diretso na yung load dito since wala na siyang kasunod ng problem. Klaro man? So, the same syntax. Ang nagbago lang yung matrix. Okay, so here, we just calculated the values. Okay, ito yung answers. Okay, I will show you ulit sa calculator natin. That will be the apps times transpose 2. And by the way, negative siya. Negative. Then, hanapin yung matrix A. Matrix A, 3. Then, inverse. Then, hanapin yung matrix B, 4. 1. Then, press equals. Yun. Ito yung magiging answers natin. Okay, now, as you observe, no? Negative ang member AB. Klarong-klaro man siguro. If this force will act towards that, that means this member AB will be in compression. And this member AD and AC dapat mag-tension sila, okay, to resist this force. Kaya naging positive yung member AC and AD. Okay.